Hello my dear students. Welcome to Teacher at Home. Today class we are going to learn the 8th chapter, second part, that is friction. Recall some of your experiences. A ball rolling around the ground gradually slows down and finally comes to rest. അല്ലെ ബോൾ ഗ്രൗണ്ടിൽ നീങ്ങിക്കൊണ്ടിരിക്കുമ്പോൾ പെട്ടെന്ന് തന്നെ അത് പതുക്കെ നീങ്ങുള്ളൂ, പിന്നെന്താണ് അനങ്ങാതെ നിൽക്കും. When we stop pedaling its bicycle gradually slows down and finally അല്ലെ പെട്ടെന്ന് തന്നെ നിൽക്കുകയല്ലേ ചെയ്യുക, എല്ലാം ഒന്ന് സ്ലോ ആയിട്ട് പിന്നെ അത് റെസ്റ്റിലേക്ക് വരികയാണ് ചെയ്യുക. Car or scooter also comes to rest once its engine is switched off. Similarly, a boat comes to rest if you stop rowing it. Can you add some more such experiences? In all the situations, no force appears to be acting on the objects. As their speed gradually decreases, they come to rest after some time. What causes a change in their state of motion? Could some force be acting on them? Can you guess the direction in which the force must be acting in each case? The force responsible for changing the state of motion of object in all this example is the force of friction. It is the force of friction between the surface of the ball and the ground that brings the moving ball to rest. Similarly, friction between water and the boat brings it to stop once you stop rowing. Force of friction always acts on all the moving objects and its direction is always opposite to the direction of motion. Since the force of friction arises due to contact between the surface, it is also an example of contact force. We will learn more about this force in chapter 9. You may be wondering whether it is essential for the agent applying a force on an object to be always in contact with it. Let us find out. Non-contact forces. Magnetic force. Activity 8.6. Take a pair of bar magnets. Place the longer side of one of the magnets. Over 3 round-shaped pencils or wooden rollers as shown in the figure. Now bring one end of the magnet near the end of the magnet placed on the rollers. Make sure that the two magnets do not touch each other. Observe that. What happens? Next, bring the other end of the magnet near the same end of the magnet placed on the rollers. Note what happened to the magnet placed on the rollers every time and the magnet is brought near it. Does the magnet on the rollers begin to move when the other magnet is brought near it? Does it always move in the direction of the approaching magnet? അപ്പോൾ എല്ലാ ഭാഗത്തും മാഗ്നറ്റ് കൊണ്ടുപോകുമ്പോൾ അതിൻ്റെ മൂവ്മെൻ്റ് അനുസരിച്ചിട്ടാണോ അത് നീങ്ങുന്നത്? What do the observations suggest? Does it mean that some force must be acting between the two magnets? I learned in class 4, the like poles of two magnets repel each other. ഒരേ ചാർജ് ഉള്ളത് റിപ്പൽ ചെയ്യും, അൺലൈക്ക് പോൾസ് ആകുമ്പോൾ അട്രാക്ട് ചെയ്യും. പോസിറ്റീവ് നെഗറ്റീവ് ആകുമ്പോൾ അട്രാക്ട് ചെയ്യും. Attraction or repulsion between objects can also be seen as another form of pull or push. Do you have to bring the magnets in contact for observing the force between them? A magnet can exert a force on another magnet without being in contact with it. Force exerted by a magnet is an example of non-contact force. Similarly, the force exerted by a magnet on a piece of iron is also a non-contact force. Electrostatic force. Activity 8.7. Take a plastic straw and cut it into nearly 2 equal pieces. Suspend one of the pieces from the edge of the table with the help of a piece of thread. Now hold the other piece of straw in your hand and rub its free end with a sheet of paper. Bring the rubber end of the straw near the suspended straw. Make sure that the two pieces do not touch each other. What do you observe? Next, rub the free end of the suspended piece of straw with a sheet of paper. Again, bring the piece of straw that was rubbed earlier with paper near the free end of the suspended straw. What do you observe now? A straw rubbed with a paper attracts another straw but repels as it has also been rubbed with a sheet of paper. A straw is said to be acquired electrostatic charge after it had been rubbed with a sheet of paper. Such a straw is an example of charged body. The force exerted by a charged body or another charged or uncharged body is known as electrostatic force. This force, the force exerted by a charged body, ഒരു ചാർജ് ആയിട്ടുള്ള ബോഡിയിലുള്ള ഒരു ഫോഴ്സ് വേറെ ഒരു അൺചാർജ് ബോഡിയിലേക്ക് എക്സേർട്ട് ചെയ്യണതിനെയാണ് ഇലക്ട്രോസ്റ്റാറ്റിക് ഫോഴ്സ് എന്ന് പറയാം. This force come into play even when the bodies are not in contact. Electrostatic force, therefore, is another example of non-contact force. You will learn about the electric charges in chapter 12. Gravitational force. You know that a coin or a pen falls on the ground when it slips off your hand. Leaves and fruits also falls to the ground when they had detached from the plant. Have you ever wondered why it is so? When the coin is held in your hand, it is at rest. As soon as it is released, it begins to move downwards. It is clear that the state of motion of the coin undergoes a change. Can this happen without force acting on it? Which is this force? Objects or things fall towards earth because it pulls them. This force is called the force of gravity or just gravity, that is the attractive force. The force of gravity acts on all objects. The force of gravity, it acts on all of us all the time without our being aware of it. Water begins to flow towards the ground as soon as we open a tap. Water in rivers flows downward due to the force of gravity. Gravity is not a property of the earth alone. In fact, every object in the universe, whether small or large, exerts a force on every other object. This force is known as the gravitational force. Pressure. Is there any relation between the pressure and force? Let's find out. Try to push a nail into a wooden plank by its head. Did you succeed? Now take to push the nail by the pointed end. Can you do it this time? Try cutting vegetables with a blunt knife and then with a sharp knife. Which is easier? Do you get the feeling that the area over which the force is applied, for example the pointed end of the nail, play a role in making this task easier? Force acting on a unit area of a surface is called pressure. Pressure is equal to force by area on which it is acted. At this stage, we consider only those forces which act perpendicular to a surface on which the pressure is to be computed. I now understand why potters place a round plate on clothes on their heads when they have to carry heavy loads. By doing this, they increase the area of contact of the load with the head. Since the pressure on the head is reduced, they can find it easier to carry the load. Note that the area in the denominator in the above expression. So the smaller the area, larger the pressure on the surface for the same force. The area on the pointed end of the nail is much smaller than on the head. Same force therefore produces a pressure sufficient to push the pointed end of the nail into the wooden plank. Can you explain now why shoulder bags are provided with broad straps and not thin strap? And why the tools meant for cutting and piercing always have sharp edges? Do liquids and gases also exert pressure? Does it depend on the area on which it acts? Let us find out. Pressure exerted by liquid and gases. Take a transparent glass tube of plastic pipe. The length of the pipe tube should be about 25 cm and its diameter 5 to 7.5 cm. Also take a piece of thin sheet of a rubber, good quality rubber, say a rubber balloon. Stretch the rubber sheet tightly over one end of the pipe. Hold the pipe at the middle, keeping it in a vertical position. Ask one of your friends to pour some water in the pipe. Does the rubber sheet bulge out? Note also the height of the water column in the pipe. Pour some more water. Observe again the bulge in the rubber sheet and the height of the water column in the pipe. Repeat this process for a few times. Can you see any relation between the amount of the bulge in the rubber sheet and the height of the water column in the pipe? Activity 8.9. Take a plastic bottle. You can take a discarded water or soft drink bottle. Fix a cylindrical glass tube a few centimeters long from its bottom as shown. Can do so by slightly heating one end of the glass tube and then quickly inserting it near the bottom of the bottle. Make sure that the water does not leak from the joint. If there is any leakage, seal it with molten wax. Cover the mouth of the glass tube with a rubber sheet as you did. Now fill the bottle up to half with water. What do you observe? What is the rubber sheet fixed to the glass tube bulge this time? Because some more water in the bottle. Pour some more water in the bottle. Is there any change in the bulge of the rubber sheet? A liquid exerts pressure on the walls of the container. Note the rubber sheet has been fixed on the side of the container and not at the bottom. Does the bulging of the rubber sheet in this case indicate that water exerts pressure on the sides of the container as well? Let us investigate further. Take an empty plastic bottle or the cylindrical container. You can take a used tin can or used plastic bottle. Drill 4 holes all around near the bottom of the bottle. Make sure that the holes are at the same height from the bottom. Now fill the bottle with water. What do you observe? Do the different streams of water coming out of the holes fall at the same distance from the bottle? What does this indicate? Can you now say that liquid exert pressure on the walls of the container? Do gases also exert pressure? Do they also exert pressure on the walls of the container? When you inflate a balloon, why do you have to close its mouth? What happens when you open the mouth of an inflated balloon? Suppose you have a balloon which has holes. Would you be able to inflate it? If not, why? Can we say that air exerts pressure in all directions? Do you recall what happens to the air in the bicycle tube when it has a puncture? Do this observation suggest that air exerts pressure on the inner walls of the inflated balloon of the tube. So we find the gases to exert pressure on the walls of the container. Atmospheric pressure. You know that there is air all around us. Envelope of air is known as atmosphere. Atmospheric air extends up many kilometers above the surface of the earth. Pressure exerted by this air is known as atmospheric pressure. We know that pressure is force per unit area. If we imagine a unit area and a very long cylinder standing on it filled with air, then the force of gravity on the air in the cylinder is the atmospheric pressure. But how large or small is the atmospheric pressure? Let us get an idea about its magnitude. Take a good quality rubber circle. It looks like a small rubber cup. Press it hard on a smooth plain surface. Does it stick to the surface? Now try to pull it off the surface. Can you do it? When you press the sucker, most of the air between its cup and the surface escapes out. The sucker sticks to the surface because the pressure of the atmosphere acts on it. To pull the sucker on the surface, applied force should be large enough to overcome the atmospheric pressure. The activity might give an idea about the magnitude of atmospheric pressure. In fact, it would not be possible for any human being to pull the sucker off the surface if there were no air at all between the sucker and the surface. Does it give an idea how large the atmospheric pressure is? The force due to air in a column of height of the atmosphere and area 15 centimeter multiplied 15 centimeter is nearly equal to the force of gravity on an object of mass 225 kg or 2250 Newton. The reason we are not crushed under this force of gravity is that the pressure inside our body is also equal to the atmospheric pressure and balance the pressure from outside. Do you know Otto van Guericke, a German scientist from the 17th century, invented a pump to extract air out of the vessel. With the help of this pump, he demonstrated dramatically the force of the air pressure. He joined two hollow metal hemispheres of 51 centimeter diameter each and pumped out of them. Then he employed 8 hoses on each hemisphere to pull them apart. So great is the force of air pressure that the hemisphere could not be pulled apart. Keywords: atmospheric pressure, contact force, electrostatic force, force, friction, gravitational force, gravity, magnetic force, muscular force, non-contact force, pressure, pull, push. What might have you learned? It is what you have learned. Force could be push or a pull. A force arises due to the interaction between two objects. Force has magnitude as well as direction. A change in the speed of an object or the direction of its motion or both implies a change in the state of motion. Force acting on an object may cause a change in its state of motion or change in its shape. Force can act on an object with or without being in contact with it. Force per unit area is the pressure. Liquid and gases exert pressure on the walls of their containers. Pressure exerted by air around us is known as the atmospheric pressure. So that's all about this chapter. If you are interested, please do like, share and subscribe my channel. Okay, thank you.